Hello, good morning, good afternoon, good evening, wherever you're in this world. Thank you for taking time to attend. On behalf of all India Oracle Users Group, a very warm welcome to AIOG weekly webinar series. And today is a Friday. It's very, I'm sure everybody is waiting for the weekend. So before I introduce today's speaker, I think most of you know about All India Oracle Users Group. This is, you can call as a platform where we can share knowledge, gain the knowledge, and important thing is networking with fellow Oracle community members. Currently, it's not happening face to face, but at least we encourage you to do virtually using Twitter platform or LinkedIn. It's very important to build this virtual network, for a career perspective, right? So please share with your connections the upcoming sessions, and that way we can get more people. More people are joining, more questions and more knowledge, right? So this month is dedicated to performance tuning, and you can see you already attended 3 sessions from starting with Chandan, Vivek, and Karan last week, means Wednesday. And today we have a really great speaker. I'll introduce in a few seconds. Before that, the housekeeping rules. It's very important. Please ask your questions in the Q&A. You can see bottom of your screen, right? Don't ask in the chat. And obviously you can ask any support in the chat or any general questions and comments in the chat box, not in the Q&A. So please ask all your questions in the Q&A. Continue your conversations in the Twitter using AIOG hashtag, and we will upload the presentation material. And if you want to if you want to contact us, the preferred way is the Telegram, or you can send an email to webinar@aiog.org. So one of the thing is we have Oracle certification vouchers. So we will pick some 3 to 4 people in this webinar. You need to ask really challenging questions to the speaker. Speaker will nominate 4 people, and they will get a Oracle certification vouchers. And I do apologize for the delay because we have some challenges, but definitely we will do it in this weekend. We are all volunteers. We have our own challenges, so we definitely send the communication of Oracle certifications vouchers in this weekend. So please check your mailboxes. If not, please ping us in the Telegram, right? Okay. Hope chat is okay. Okay, that's fine because I was thinking panic four questions in the chat window. Okay, so today's speaker, Toon Koplars, hope I pronounced properly. If not, we like to call Toon. It's a short name. So Toon has been part of Oracle ecosystem since 1987. He's currently a member of Oracle Real World Performance Team. I don't know how many of you know a Real World Performance Team means. It's basically the experts, or you can say a scientist, part of Oracle database, and they do started with a day of a real world database performance. They come and present. I think I have included that in the next slide. So let me go to the next slide. You can see these are the memories, where Toon was there in 3 cities in India with other folks. And it is really great sessions. They discuss the real world performance problems with the applications. It's really great. And we want to see these type of sessions as soon as possible. As you know, this pandemic is killing all this networking events. But coming back to Toon's profile, so it's important thing is the way application currently uses the RDBMS is often at the root of these performance issues, right? So it's a very deep level. It's not like, very high level. It's a very deep level. You can see the 3 speakers are discussing about the same topic in different ways. So I'll leave it to Toon to introduce, but it's very important to attend these sessions. And these are the very, very fundamental and important sessions to attend. So with that, very warm welcome to Toon from Netherlands, and please take over, Toon. Start sharing your screen. Thank you very much.
Yeah, thank you very much, Sai.
Yeah, we can see your screen.
Okay. Okay, welcome everybody. So today I would like to talk about an hour on this very important thing, SQL Monitor report. Very important if you want to look at the performance of SQL statements that are not running as fast as you would like them to run. I'm assuming that many of you have never used these reports, so this will be I will start off with an introduction into the report. I will explain what this report is all about, all the sections that are in the report, where you can see lots and lots of runtime information of the execution of a SQL statement. So that will probably be like 30, maybe 40 minutes. And then I'll do two simple examples. I'll look at two simple SQL statements and show you how we use these reports in order to diagnose the performance and find the root cause of the slow running of this SQL statement. Yeah, so again, the goal mainly is an introduction and show you the wealth of information that is in such a report, and you really should start using these reports if you want to diagnose a SQL statement's performance. Yeah, so of course we have lots of diagnostic tools in the database. So whenever you are asked to improve a query, and of course this never happens to you, right? Well, where do you start? We have AWR, we have ADDM, part of AWR, also SQL Trace, TK-Prof, Explain Plan, Active Session History, SQL Monitor, lots of $, $X views. And of course, you have third-party tools. Often those third-party tools will have to use one of the above. And I hope you'll not be guessing what's going wrong with the SQL statement, but actually use the appropriate tool when you want to diagnose an issue. So from these tools, I just want to briefly choose three and give the main reasons why we have these. So Active Workload Repository Report, AWR report, that would be the tool if you need to diagnose the performance of a whole database instance, because it shows what the database instance has been doing, where it has been spending its time. It's a huge HTML file. I can do a separate session just on AWR. But if you want to look at a more detailed level, the next level down would be to look at what a database session is doing. And there you have the tools such as Active Session History, ASH, or my personal favorite still, just SQL Trace with the trace file and TK-Prof, to take a look at what is one database session, for instance, a session that's executing all the statements of a batch process. What is it doing time-wise? But today's topic will be about even further down into the detail, diagnosing the time spent by a single execution of a SQL statement. So I have one statement and that's running too long and I want to diagnose its time. And that's where we have SQL Monitor as the tool of choice for you to use and start diagnosing the performance. Now, SQL Monitor, like AWR, is also an HTML file. Now, I have some screenshots here. I'll go through all the sections in a minute. First, what is SQL Monitor? It was released ages ago, database 11G. It was always part of the tuning pack, but if you are now using Oracle in the cloud, you always have SQL Monitor at your availability. Now, for the few people who may have been using this before, you might remember that up until last year, it was a Adobe Flash-based user interface. But since the beginning of this year, or rather the end of last year, since Flash was not supported anymore, it has been redesigned and we now use our Oracle Jet user interface toolkit. And it's a standard JavaScript HTML5 user interface. I'll show you in a second. The nice thing is that if you still have SQL Monitor reports that you generated before we switched to Jet, so that used to be Flash, when you now open them, they automatically are just a standard HTML5 report. Again, it's always on, enabled out of the box, but it's not on for every statement. I have here at the bottom, these are the 3 types of statements that we will monitor. Whenever your statement is using parallelism, so runs at a certain degree of parallelism, all those are monitored by default. If you're not using parallelism, but you have a statement that's executing in a single thread, in a single session, so that's what we call serial statements, they won't be monitored unless they run more than 5 seconds. The moment they run more than 5 seconds, we start monitoring them, and you will have the monitor report available for you to download. The other types of statements, you can always force a SQL statement to be monitored, and that's via the monitor hint at the top level in the SQL statement. Now, the nice thing about SQL Monitor is, if let's suppose you have a statement that runs for 60 minutes, you don't really have to wait for the full 60 minutes. You can wait for like 20 minutes, and then 20 minutes into the execution, you can run already the SQL Monitor report. So at any point in time during the execution, you can run the SQL Monitor report and see what has been happening up until now. But of course, you can also wait for it to finish and then get the full SQL Monitor report of the finished statement. Now, there are 3 formats available. I mentioned so far the Oracle Jet HTML5 format. That's what we call the active format. That's the one that you should always use. There are still 2 legacy formats available, the text and the HTML format. Please don't use those anymore. Always go for the active. Now, the nice thing is, in the various monitoring screens, for instance, in Enterprise Manager or in the Performance Hub or our cloud, or if you are using Enterprise Manager Express or even a SQL Developer, we have SQL Monitor support in these environments. You have, at certain points, you can download SQL Monitor reports, and they will always, by default, generate the active version nowadays. However, I often instruct customers, or do myself, use a command line tool to generate a SQL Monitor report. And there you have to actively choose the active version. So here is a little SQL Plus script that you can use. Once you know the SQL ID of the SQL statement for which you want to have the SQL Monitor report, you have to use this package, dbms SQL SQL Monitor, and make sure you use active here, not HTML or text. And then you supply the SQL ID. And by spooling it here and stop spooling it here, it will generate the HTML file. Of course, you have to make sure you set some things correctly in SQL Plus to make the spool go correctly. Now, if you have a SQL statement, most of you probably know it has a SQL ID. What I sometimes find is that people don't understand that there's also this other concept called an execution ID. If I run a SQL statement multiple times, each run of the SQL statement will get a new execution ID. So it can be that you have in the instance run the same SQL statement twice, and it will have 2 SQL IDs, sorry, execution IDs. When you run the monitor like I have on the screen here right now, it will by default generate the report for the most recent execution ID. In $SQL Monitor, you can see all the SQL IDs and their execution IDs and when they ran. So if you want to generate the SQL Monitor report of a different execution ID, you have to actually supply a 3rd parameter here, being the execution ID. I'll have that on the slide, 2 slides down from here. And there's also a different package, dbms SQL Monitor.report SQL Monitor, but it's basically the same function. It's all available in 2 packages. So normally you would reproduce in SQL Plus and then immediately generate the SQL Monitor report while it's still fresh in memory in the SGA of the instance. And it will give you a report that has that looks like this. And I'm going to talk you through all the sections here. You see we have 1, 2, 3 top level sections, and we have a main section here at the bottom, but there's actually 1, 2, 3, 4 different tabs here also. So let's start with this section here, and let's do that via the live SQL Monitor. I have all the screenshots in the slides, so you can have the screenshots. You can look at the screenshots later when you get the slides. So here I have the SQL monitor report of a query. Now you see the SQL execution ID, and you see that this one has finished successfully. In the top level section at the left, we see the SQL text. We see a bit of the SQL text. And when you click on it, it will open the SQL text tab where you can see the full SQL text. And what we also see here is when did this statement run? When was the execution started? When was the last time we sampled this statement while it was still executing? And you see that SQL execution ID. Yeah, so of the exact execution of this SQL statement. The other things we can see here is what was the username, how was the user connected into the database. In this case, it was a SQL Plus user connecting to the other groups, consumer group. And you also get the module and the server, the module and the service that was used to connect to. We see that since it's a SQL since it's a select statement, the application has to issue fetch to get rows, and in this case, the application only issued one fetch call. Now, the other thing here at the top level is what we call execution plan information, and it's actually showing when we run in parallel what was the degree of parallelism. So here the degree of parallelism was 32, and apparently the execution plan required 2 parallel sets to execute this execution. So we allocated 64 parallel execution servers. And they were allocated across 8 instances in this case. Yeah, so you can see a detailed, sort of a top level information. How did this DOP operate for this statement? There's much more information in the parallel tab, which I will show in a second. Now, what can also happen, and I want to make this point right here now, is statements that are requested to run parallel can be downgraded to a degree of parallelism that is less than the degree of parallelism that you want the statement to run at. And when you get a downgrade, I have a second SQL monitor here, you'll see that via this down arrow. So here in this case, we requested 16 servers, so the degree of parallelism was 8, but we only received 6 servers, meaning we will run at a DOP of 3. Now, the thing that's interesting to find out is why do you get a downgrade if you get a downgrade? And the SQL Monitor report actually has that information. If you want to find out, whenever you see that down arrow, what was the reason, you have to go to the Plan Statistics tab, and I'm just going to minimize this top level section here, and find the row that has the coordinator. So this is the top level parallel execution coordinator. On that row, you see these binoculars, other information, and there you see a reason. That's the downgrade reason. Now, of course, 352 isn't going to tell you much, right? But you have to then also look up the reason, and we have a view for that, and it's in the slides here. These are all the screenshots of what I'm talking about. So there's an $X view where you can find the reason, and it actually depends on the version that you are on. In most recent versions, the 352 reason is this was a downgrade due to adaptive degree of parallelism, saying, well, it's a bit busy at the system now. You want 6, but I'm only going to give you a DOP of 3. Yeah, so that's the reason. I basically have this in a text file so that I can quickly see the version of that the customer is using, and when I see a downgrade, what was the actual reason. So that's the first section. Some information about the SQL ID, when did it run, did it use parallelism or not, etc. Now, the second section, the middle section, shows you how long did the statement run. Yeah, in this case, it ran 40 seconds. So that's the running duration, the wall clock time. And during those 40 seconds, of course, I had multiple processes working on this execution. So the database time will be much more because each process will accumulate database time while it is running in parallel. So of the 40 seconds duration in the database, all those processes have spent 16.5 minutes working on this execution. And almost 70% of that was CPU, and the rest of it was I/O. Yeah? So here in database time, you see the top level weight classes breakdown of the database time that was spent working on this execution plan. In the activity tab, you see the actual wait events. Of course, CPU is CPU, but here the I/O will be broken down into, well, it was I/O to the temporary table space. So both read as well as write. And we also got some cell smart table scans. And this is a little bit of stuff going on between the parallel execution servers. Yeah, so the 100% indicates this is the breakdown of the 16 minutes. Yeah, so I now know it runs for 40 seconds and it spent a good 16 or 17 minutes in the database across all those 32 processes. Now the third section has a bit of more information on the I/O spent by this execution plan. Here we see the buffer gets, so how many of the 8K blocks that the execution required were were serviced from the buffer cache area in the SGA. And we see the number of actual physical I/O requests and I/O bytes. Yeah, so actually the pop-up here, read requests, read bytes, is actually the same as the pop-up here, but from the read requests and the read bytes, you can calculate an average I/O size, which is also shown here. And this is both for the read as well as for the darker brown, the writes. The number of requests, the number of bytes, and the average I/O size. Okay, now if the execution plan involves a smart scan, so if you run on Exadata and there is a smart scan somewhere, you'll also see cell offload efficiency. We have a pop-up there also. So in this case, the smart scan or multiple smart scans, I haven't looked at the execution plan yet, the smart scans required 181 gigabyte to be read from the disks in the storage layers, but only 122 gigabyte were returned from the storage layer to the database instance. Yeah? So the difference between the 181 and the 122 is what we call the cell offload efficiency. Yeah? So it actually returned less bytes to the database instance than were necessary to be read. That's because of all the smart filtering going on down in the storage cells. Actually, 32% is not a very high percentage. You typically want much higher percentages for smart scans to be at the top level section here. Yeah, so just looking at these three top level sections, I've not even yet looked at the SQL statement or at the execution plan, but I have a good idea of the runtime behavior of this particular statement. So these are all the screenshots that I talked about. Oh, sorry, and now I have to go to the... So now we're going to look at the plan statistics tab, and I want to highlight these columns first here, and also the one here in the middle. So minimize the top section again, so we get a full overview of the plan statistics. So here I see the SQL execution of this rather simple SQL statements. It's a left join between a car guys table and a car guys table with a bunch of predicates and also a join condition here. And we see the execution plan here in these in the first column. What you also see here is per row, which process or processes were working on that particular row source. Yeah? So the top level ones were done by the coordinator. And here we see that a parallel set 1 was working on these ones, and a parallel set 2 very likely was working on those, and parallel set 1 was again working on those. When we do a parallel execution, these parallel sets, they take turns in executing bits of the execution plan. Very important two columns are these two here. What did the optimizer estimate as the number of rows coming out of each of these row sources? And during the run, what were the actual number of rows produced by these row sources. You typically want these two to be the same kind of numbers here. I'll have an example later where that's definitely not the case, and show you how you can then diagnose the execution plan. Now, the other important one is this activity column here. Let's open up the top one again. So what we saw here as the activity for the full execution plan, you now see the breakdown. You see the breakdown of this per execution line. Yeah, so we immediately see that most of the time was executed doing this hash join for this particular statement. That's almost 80% of the time was spent in that operator of the SQL statement. Finally, the thing that I want to show you here is the information column. And you can make these things a bit wider or less. And there we have the filters. Yeah, so here we see the filter that was used when this full scan was operating. And there's another filter here. The filter that was used when the other full scan was operating. And we also see if the tables were partitioned, whether partition pruning was happening. So apparently here we only scanned for 13 partitions, partition 1 up to 13. And we have partition pruning information here also. And the last thing on these full scans is basically the more detailed information about the smart scan. I'm not going to discuss these in detail right here now, but this is the information for the first smart scan. That's the information for the second smart scan. So those are the more detailed informations which eventually created this 32%. Finally, if there is a join operator, you see this yellow thing here, and there you see the join condition that was going on in this hash join outer. Yeah, so that would correspond. Sorry, that would correspond to this join condition in the SQL text. On the joins, again, you see if it's a hash join, a lot of the inner workings of the hash join. I must confess, I do not look a lot at this type of information unless the hash join is really an issue. But often I don't need to look at this information. And in order to understand these numbers, you would really have to understand the inner workings of a hash join, which is not the topic of this today's session. Yeah, so the execution plan, which processes worked on the lines, estimated rows, actual rows, where did we spend most of the activity, and then the information coming out of the SQL text, where were the filters and the join conditions. The IO requests is basically a breakdown, of this one. Yeah, so this is the top level number of IO requests, and in the column here you can see the breakdown of that number over the execution plans. Oh, I forgot one important thing. I always forget this one. Plan notes. If you start looking at an execution plan, always click on plan notes. In this particular case, there's not much interesting information in here, but there can be all kinds of information in here. For instance, a few weeks ago, I was diagnosing a delete statement. A delete statement was taking way more longer than you would expect it to take. And in the plan notes, there was a line here that says that said that cascade deletes were going on. So apparently the delete statement was operating on a table that had foreign keys declared against them, and the foreign keys were declared as cascade delete. So when you delete a parent row, then the database will automatically also start deleting child rows in other tables that the foreign keys point from. So the plan notes, it can be all kinds of things that you suddenly see in the plan notes. Again, here there's not much interesting information, but always quickly open it and see if there's something interesting in there. So that's the first tab of the main section. Again, I have the screenshots here. Now let's move on to the parallel tab. So in the parallel tab, you see much more detailed information of what we saw here at the top level section. We already knew this ran at a DOP of 32 and was running across 8 instances. So what we see here is per instance, instance 1, instance 6, instance 5, all the way up to 8 instances, the parallel sets that were allocated there. And then per instance, you see again the breakdown of the database time. So here I'm just opening one parallel set. So in this parallel set, we had 4 servers running at that time. And what you want to validate here is see if each server sort of uses the same amount of time. Yeah? So here they're all using 26, 27 seconds. If I just open another one, you should see that the time spent within a set is probably the same size. So here again, it's all 3.5 seconds. So that's good. Because if you don't see that, and if you see a case where one is using a lot more database time than another one, and we can do a second session, Sai, at some point where I go through many more of these examples. Then we have what is called parallel skew, and the server that needs to work on a lot more work than the other ones is basically becoming the bottleneck. Yeah, but here in the parallel tab, you see you can find out if skew is happening or not. So the SQL text, we already discussed that. The next one is the activity tab. In the activity tab, you see the activity broken down across the 40 seconds. So here I have a timeline of 40 seconds, 12:53:05, 12:53:40, 40 something. And I usually untick this one so that the bars are a little bit bigger. And you can see during those 20 seconds how this database time was accumulated. Yeah? And one of the interesting things in this particular case is here we have a whole big section. There's a big section where we're not nearly accumulating 32 at a factor of 32 database times. So this would indicate to me that from here till there, many of the parallel execution servers weren't working on my execution plan. Yeah? And that then might be an area where you would want to dive into and trying to understand that. The other thing I want to show in this activity tab, I'm only going to show you now the wealth of information in here. I have 2 examples where I will start doing the actual diagnosing, is you can switch to plan line. Yeah, so by default, it has by resource type. So across the 20 seconds, we can see all kinds of wait classes or wait events that were happening during those 20 seconds. But you can also click plan line, and here you can see per plan line when the plan line was active of the execution. So we see the big one being the line 5 hash join that's active basically the whole time, the whole 20 seconds. Yeah, so that was this guy at line 5. Here in timeline, you basically see the same information. It's active most of the 20 seconds. Whereas the other lines, they are active only at the end of the execution. But in the activity tab, you can see a much more detailed breakdown of this activity. And then the last one that I want to show you is various graphs here. And again, they are plotted against the 20 seconds. So we have the timeline of 20 seconds all across these horizontal axes here. The CPU used, the PGA, so the memory allocated in the SGA for executing this SQL statement, which at some point was 32 gigabyte. Also, the temporary table space used during the 20 seconds. Yeah, at the maximum here, we were using 64 gigabyte of temporary table space. That figure, by the way, is also here in the temp max column. you see that the 64 gigabyte at some point were used by this hash join right outer, probably because the build table, if you have a hash join, you have one of the row sources needs to be hashed as into a build table in memory, probably because the build table was too large, it didn't fit in memory, so we had to spill to disk. Yeah, so that's the temp usage. And we can also see the I/O rates that we get from our I/O system, both reads as well as the dark brown, the writes. And if you have Exadata, the I/O rates across the interconnect between the database instance and the storage cells. We have a second tab here, the buffer cache, which shows the rate at which we read 8K blocks from the buffer cache pool during the 20 seconds. And here, the last one, the I/O requests. Basically, we see here that mostly at the end, we were writing and reading a lot into the temporary table space. Again, that should be visible here also. Here we see the direct reads and where are the writes? Oh, the writes are just in front of it. We start creating temporary table information and we start reading temporary table information. We start writing it and then we start reading it during the execution of this plan. So that's the wealth of information that you have available in this SQL Monitor report. Now, one last thing I want to bring to attention is this here, the time zone. So very often nowadays, it can be the case that your application or that your users are in a different time zone than is your database instance. By default, it will open up here in the time zone of the browser, which for me is GMT +2. But if I want to see what was the time zone at the database in here, I switch to database. And now you didn't probably see it, but these times now changed. And this might be really useful if you are contacting a DBA and you need to synchronize the times at which things ran or things happened. Make sure you use the database time zone, because these now reflect the database times locally to wherever the database was located. Okay, so the parallel tab, I talked about that. The activity and the metrics tab, I have it all here in the slides. You can go through them. I'll also upload the SQL monitors that I used, so you can have a look at those SQL monitors yourself also. So now, finally, how do we use a SQL monitor report? Well, you've basically seen me doing it. We always read those 3 top-level sections first, so that we have some kind of feeling what type of time are we spending, what type of IOs are we doing, what's the statement, what's the degree of parallelism, etc. We always do that first. And once we have done that, we go to the plan statistics tab and try to understand where is the time spent on which line, and then why are we spending time there. Very often, as I mentioned earlier, it's because the cost-based optimizer had made an error in estimating the number of rows for a particular execution line. And I'll have an example of that. Let's go to that example right now. It's a very simple example. I have a query from line order with a predicate, customer key equals 101, and I'm just selecting the sum of the tags values and the count of the part keys. Now, this statement ran in 3 seconds, and we are asked to see if it can run faster. Now, let's go and look at the full SQL Monitor report. So here we have the SQL Monitor report. Now, that's the same query I had on my slides with the sum and the count. And let's start with the top level sections. Yeah, so what we see here is that the parallel information is missing. So if we don't run in parallel, we actually don't show it. So the fact that it's missing immediately tells us that this was not running in parallel, it was a serial execution. And we see when it ran, and it issued, it's a query, it issued a single fetch call. So not much here to see. That's the SQL ID, and it actually executed till the end. Here's again the 3 seconds. Because it runs so short, there's a bit of a rounding error here, but we have the same kind of time in the database, 3 seconds, and it was all CPU. Everything was CPU. In the I/O section, we see there's no I/O happening at all. All was CPU doing cached buffer gets from the SGA, from the cache pool. Now, let's look at the execution plan. So of the 3 seconds that we have here, we are spending 2 seconds on this execution line and 1 second on this execution line. Yeah. So what we also see is that the optimizer chose to use an index range scan, because there's an index on the customer. Yeah, so there we have the customer ID equals 101, which was the bit in the where clause. So we use the index to get the rows. And then we get the rows via table access by row ID from the table line order. And that's where we spend most of the time. Yeah, well, we're getting rows. So we're spending, this is basically the fastest way to get a row, right? I mean, if you have the row ID, what's the fastest way to get to the data? Well, by table access by row ID. So how can we speed this up? I mean, it's a very simple query. Well, we weren't using parallelism, right? Let's throw some parallelism at it. So I've now added a hint just to force, just run this in parallel. Let's see if it runs faster. So I added a hint, parallel 16. And it actually now ran at a degree of 16. And this is a very simple execution plan. It only required one parallel set. So we get 16 processes that start working on this execution plan. So the 3 seconds now drop to 1 second. Well, that's good. We run 3 times fast. Well, is that really good? I mean, we're now using 16 more processes. But we only get a speed up. We only get a speed up of 3x instead of 16x. Yeah. So that may not be good. Let's look at the execution plan. Well, it's now using a table access storage full. Yeah, so it's not doing the index anymore. But we now push this predicate into the smart scan, into the storage layer. And we actually get a really good cell offload efficiency. Yeah, we hear it. Apparently, we needed to scan. Let me see. We needed to scan 1.7 gigabytes at the storage layer, and the filter was processed in the storage cells, and we returned only 8.4 megabytes. Yeah, so we have really, really good offload efficiency, rounded up to 100% for this case. But still, we run in 1 second. Yeah. For these kinds of statements, where you already run fast, throwing parallelism at it, you need to be aware that starting 16 of these servers, and then having them process 1/16 of the full table scan each, and communication going on between these processes, we also introduce some overhead, right? And it's the overhead of the parallel execution that makes this statement still run in 1 second. Because if you look at each parallel server, it's just milliseconds work. But the overhead of creating a parallel plan and the communication between these processes then kills the performance again. So we don't get a 16x improvement, but only a 1 second improvement. Well, let's have a look at the original plan. We knew that most of the time was spent on these 2 row sources. But let's investigate the plan a little bit more. Let's look at the estimated rows versus the actual rows. There's a huge mismatch here, right? The optimizer thought that this predicate would only fetch 4 rows from the line order table via the index on the customer ID. It thought it would only fetch 4 rows. Well, if you think you only fetch 4 rows, then doing an index is a good choice. But actually, we didn't get 4 rows, we got 8 million rows. We got 8 million rows. So that means that we are executing 8 million row ID, table access by row IDs on the line order table. Yeah, and doing 8 million fast lookups by row ID still takes time because you do it 8 million times. Yeah? So this may not have been the correct choice, doing an index range scan, because apparently the statistics aren't up to date. And that was actually the case in this execution plan. There was a huge load done and the statistics weren't refreshed. And apparently customer 101, for customer 101, a huge number of line orders were loaded, but the statistics didn't reflect that yet. So let's fix this first without doing any parallelism yet. Let's make sure the optimizer knows how much rows customer 101 has. So we're now going to regather the statistics on the table and then rerun the statement. Now, if we now rerun the statement, we now see that the optimizer has much better idea of the number of rows that this predicate will produce. It thinks almost 8 million, it gets 8 million, so it's spot on now. Because the optimizer now knows this number of rows, it decides, well, I'm not going to do an index range scan for those number of rows. I'm going to do a full table scan, because that's much more efficient if you want to access so many rows. So we're going to do a full table scan without an index range scan, and we get the 100% offload efficiency again. And look at the time. We now run in 0.2 seconds. By just telling the optimizer, these are up-to-date statistics. The optimizer chooses a different execution plan and comes up with a much better execution for this SQL statement. So that's the first example. One last point I wanted to make about the original plan is, so the index range scan, index range scans can be really fast, even if they have to fetch 8 million row IDs. That's not the issue here. The index range scan, you think it's not the issue here because you see the big bars here. But the point is, the root cause was this line. The root cause was the index range scan, which then gave rise to all the time spending up here. So very often, if you look at the activity bars over here, you start looking at execution lines in the execution plan, but they may not be the root cause. Actually, the root cause is often at a different line. So you need to understand these execution plans. You need to be able not to just read an execution plan, but also know what that means, how it operates. And from that understanding, you can then deduce why we are spending so much time on certain execution lines. And in this particular case, find the reason that it's actually the big index range scan, and it's a big red flag here that these two numbers weren't the same. So I have that all in the slides here. We're throwing parallelism at it. And the root cause was this. If we fix it, we immediately run a lot faster. Now let's go to a second case. In a second case, we have a query that ran almost 40 minutes. And it's already running at parallelism. Well, not a big parallelism, but some parallelism. But let's have a look at the SQL Monitor report. So again, the SQL ID, this is a SQL monitor report when it was completely finished. We have a select statement. Let's have a look at the select statement. Whoa, there's lots and lots and lots of hints in the select statement. It's a huge query, right? It's a huge query. I'm not even going to try to understand this query. Very often, in order to fix a SQL statement, it's not necessary to understand the query. Sometimes it is, but in this particular case, I'm just not going to try and understand the SQL statement. First, see if I can understand where are we spending time. So it's a query. It ran in a certain user. It ran for 37 minutes. Now, what I immediately now see here is if this query ran for 37 minutes, how can that be? Because we're only spending 8 minutes of database time. Now, there's a big difference between these two here. If we were running for 37 minutes with a DOP of 2, I would have expected sort of 2 times 37 minutes of database time. But I'm not nearly seeing 2 times 37 minutes. Actually, I'm missing 37 minus 8 is 29 minutes. I'm missing 29 minutes of time somewhere. Yeah. The activity is, again, just the breakdown of these weight classes in actual weight events. Not the majority is CPU, but I'm not interested in that. The thing I'm interested now is where are my 29 minutes here? Why is this running for 37 minutes, but only spent 8 minutes in the database? This means 29 minutes were spent elsewhere, not in the database. That's my first top level thought right here. Yeah, I/O, again, I would not be much interested in the I/O, not at least since there's a minus 39% here. I'm not just going to even discuss that. I'm interested in why are we only spending 8 minutes in the database. So let's look at the breakdown of this. We knew it's a big SQL statement, so we see the breakdown here, and there really, there's not, well, we spend a lot of time. We spend a lot of time on lots of execution lines, right? 3, 2, 4, 6, 8, 9%. So the time is scattered throughout the execution plan. There's not really a single execution line that I can start focusing on. Yeah, but again, I'm not, that's still not my main question. My main question is, where is these 29 minutes? If I look at the activity tab for this particular case, let's untick this box again. So there's some renderings going wrong here, but what I see here is I'm actually running at the DOP of 2 in the first what, 15, 10, 15, 15, in the first 5 minutes. And then I'm not using any time at all. I mean, sometimes I'm using a little bit of time here. Here I'm not using any database time. A little bit of time again. So this is the missing 29 minutes. The statement is still running, but it's not processing in the database. It's spending time elsewhere. Well, there's more information now to look at. Maybe some of you have noticed the number of fetch calls here. We're doing 11,000 fetch calls to get the data from the database to the application. Yeah. How many rows is this query producing? This query is producing almost 3 million rows. So now things are becoming clear to me. This is a query that generates a huge number of rows, 3 million rows. And they need to be fetched from the application server to get the rows from the database to the application server. And it's done via 11,000 fetch calls, right? So what that enables me to do, and I actually do this, I'm just going to do this live here. I'm just going to start my calculator here. So I have 2.859, 2 859,000 number of rows. Let's divide that. I'm going to divide that by 11,434. So that means that each fetch gets roughly 250 rows. So we're using a fetch array size that's 250 big. That's actually already a fairly sized array size. And normally the default array size, depending on the tools that are being used, would be 10 rows. But it's already at 250. That means we're going across the network 11,000 times. And each time that we go across the network from the application server to the database server, we fetch 250 rows. So I could speed it up a little bit probably by increasing the fetch size. But this is something that the application developer has to do, because the definition of the number of the size of the array that the fetch is using is somewhere in a configuration file on the application server. If they would change the array size instead of 250 to be 500 or maybe 1,000, then the number of fetch calls would go down, which means the number of times that we go across the network would go down. And that would mean that this bit of the execution, because here we are doing all the fetches, this bit was actually the database time, producing the rows. And now we start doing the 11,000 fetches, which is why we sometimes see no activity at all, because the rows are being transferred to the application server. Yeah. So here I was able to diagnose this SQL statement by not looking at the execution plan at all, but only looking at the top 3 sections and the activity tab, and get a feeling of why do we see this behavior for the execution. Again, I have that in the slides. So in this case, increase of the array size might be an issue, but what another option might be, maybe the application server is in a different data center. If your application server and your database server are not in the same data center, you would see these kinds of issues also if you need to get many rows from the database to the application. So bringing the application server closer to the database might also be a fix. The last thing that might be the case, so every time we fetch 250 rows to the application, it could also be the case that the application server is CPU bound. So every fetch gives 250 rows, but then the application server needs to process those 250 rows. And it spends some time processing those 250 rows before it can do the next fetch call. Yeah, so it can be a combination of 3 things here for as far as the root cause of this 37 minutes. Okay, some final comments. So when might SQL Monitor not be the best approach? Well, SQL Monitor is the best approach if you have a complex SQL for which one execution takes a lot of time. You should not use SQL Monitor for simple SQL statements that get executed thousands of times, which is what you might typically see in online transaction processing systems. There you have lots of single row statements, single row inserts, single row updates or fetches. There SQL Monitor will not help you because the issue is not the elapsed time of a single execution. The issue in those kinds of environment is the number of times these statements get executed. Yeah, so that's when it might not be the best approach. A little bit more background on where are these SQL Monitor reports stored, because you need to realize that also. So once a statement is run and we monitor it because it's a parallel statement or a serial statement taking more than 5 seconds, or you have the monitor hint in it, once we start monitoring it, it's available in a bunch of $V views. A $V monitor would be the top one. There's also $V SQL plan monitor, which has plan line level information. And that gets refreshed while it gets executed. Once it's executed, the data is still in here. When you use the report SQL monitor function to get the monitor report, it reads the data from these $v views. But you need to understand that these $v views, at some point, they will age out the data. The data will not be available anymore. How long this takes depends a little bit on how busy your system is, etc. Every minute, we move things from memory into the active workload repository. And then SQL Monitor reports will be available in DBA history reports. Yeah, so every minute we capture SQL Monitor report of the top 5 SQLs by database time, ordered by database time, whose monitoring has been completed. So if your SQL Monitor report isn't available anymore, the SQL Monitor report of a SQL statement that you ran, let's say 10 minutes ago, it could be the case that it has aged out and is now available in DBA history report. If it's aged out and available in DBA history report, you should use a different package to get to the report. It's this package. Go look up in the documentation on exactly how to use this one. But it could also be that your SQL statement was not one of the top 5 statements, and then the report is gone forever. Yeah, it's gone forever. So when you do, for instance, some benchmark testing, you run lots of SQL statements, and you want the SQL Monitor reports, make sure you generate them immediately once the statements have run, because then everything is still available in memory. Yeah, sometimes you see, you try to get a SQL Monitor and it's not there. The very 2 common reasons are if it's a serial plan and it ran just under 5 seconds, well, it won't be there. You would have to add the monitor hint. The other reason for SQL Monitor information not being available is because it's a really big execution plan. And by really big, I mean more than 300 lines. There's this underscore parameter, underscore SQL max plan lines, and its default would be 300. If your execution plan is more than 300 lines, we won't monitor it. If you want a SQL Monitor, you would have to increase this underscore parameter first so that these big execution plans also get monitored. And you can do that in your session. You can just use an alter session, set double quotes, underscore SQL max plan lines, double quote equals 500, then rerun your statement and it should be monitored and you can pick it up from the $v views. Yeah, so there's some more reading here on the last slide. There's a white paper on SQL monitoring. It's a bit old. It probably has the flash screenshots, but in terms of the information, not much has changed. There's also a blog post out there from Maria Colgan. And I also added this PDF, which has some more detailed information on how to read execution plans. Again, the comment that I made is you should understand how to read an execution plan. Okay, and with that, I'm spot on 60 minutes, Sai.
Hey, thank you. Thanks, Toon. There are 31 questions, again, okay, depending on how much time you can spend.
Yeah, I have some time. Let's have a look.
Toon, if you can just read, because there are people also watching from the live channel, so they can't see the question. So when answering, just to read the question. Thank you.
Okay, 30. Yeah, so why is there a huge different estimated actual? I discussed that.
And share me the names, yeah, and also mark the questions like answer live.
Oh, okay, yeah. Okay, well, there are 33, so it's going to take me a few minutes. So, when it comes to parallel query, how can I find the duration of the SQL execution when analyzing historical SQL execution? I can find database time through DBA, but not duration. Okay, I actually don't have an answer straight for that one right now. The huge difference here, that one, I answered that one live. It did not show anything about the cardinalities and the skew data. How can real-time SQL monitor help diagnosing performance issue caused by those? Yeah, so when you have skewed data in your parallel process sets, that's a whole topic by itself. I mean, I'm happy to do a separate presentation on just that, but the big thing that you then do is, let me show you, is you go to activity and you switch to plan line, and then there will be one plan line where most of the time is spent, and that would be the plan line where the PX process that is skewed is processing most of its time. But I'm just giving you the top level answer here. That would be, again, a whole presentation in itself. Okay, why we didn't see SQL monitor cost column? Yeah, that's a good question. Why don't we see cost column? It's an omission. It will be there soon. So cost column is coming back. It's not in the current version. I expect it will be back within the next few months.
It's Kishore, right? Too. His name is Kishore. Yeah. Okay.
If I'm on Oracle Standard, so on Oracle Standard Edition, SQL Monitor is not available, unfortunately. You need Enterprise Edition because you need the tuning pack. How can we monitor the SQL plan changes proactively? I'm not sure how to answer that one. Are the estimated rows and actual rows displayed in the report? Yes, I showed that. Sometimes SQL Monitor shows plan hash value as 0 for PL SQL statements. Okay, if you have a PL SQL statement, a SQL Monitor will not help you. A SQL Monitor is really for SQL statements. You need to find the SQL IDs of the SQL statements that are executed by the PL SQL program, and then generate monitors for those SQL statements. Sometimes, even though session exists on database, SQL Monitor shows done or error. How to actually forgot to mention that. Let me go to that slide. So all the examples that I showed had this check mark, which means it's done. But you can also have error, and then it means that there was an error when this SQL execution was happening, or when you generate the SQL monitor while it was still in progress, you will get a SQL monitor that has this green sun kind of symbol here, showing it was still in progress. So when it's in error, I think currently we don't show the Oracle error. This also is in the works. We will start showing the error in the pop-up that you get here. Yeah, but it's not currently there. I think it used to be there in the Flash version, but in the new SQL Monitor, it's an omission also. Let's go back to the top. So why database time is more than duration? I explained that because multiple processes are accumulating database time when you have a parallel plan. Sometimes, even though session exists, yeah, I just did that. SQL cycle times controlling minimum time. Oh, that's I did not know that one. So there's another underscore parameter, underscore SQL recycle time, which controls the minimum time SQL monitor will be visible in the VDOL views. So that one, the retention time, that's the same kind of question, was just answered. Sometimes when execution plan is more than 300 lines, SQL monitor will not kick in. That's the one I answered on the last slide. if it's possible to identify how much time query takes to complete from SQL Monitor if query not comes in long ops. I'm not sure how to answer that one. I have observed parallel degradation of few queries. Why is this so? Well, I explained how you can find the reason. Go to the binoculars on the PX coordinator plan and then query the $X view to get the actual information. How can we kill a live session which is running from last 1 hour and user don't want that? This should be done automatically. So if you want to kill a long-running SQL session, you have to find the session ID and the serial number. So you have to query $session, find the session ID and the serial number, and then use alter-system kill session command. Just look up alter-system kill session command in the documentation. Duration 40 seconds, DB times 16 minutes. Again, that's due to the parallelism. You always get more database time than duration if you run in parallel. What if SQL query executed on remote DB using a database link? Well, if you have a bit of execution going on the remote database ID, you will not see it in the SQL Monitor. There will be just one line in the execution plan that says remote. If you want to understand the time spent remotely, you would actually have to go to the remote database, find the SQL statement that was shipped to this remote statement, find its SQL ID, and then do a separate SQL monitor on the remote database. Yeah, so that's a very tricky thing to do because you have to start monitoring the remote database and then spot the SQL ID and then actually generate a second SQL monitor on that remote database. It's a good question from Rahul Korkute. It's recommended to use SQL Monitor to analyze batch job performance, which has n number of subqueries, which alter. Well, no. So if you have a batch job that executes multiple queries, unless there's one of those queries that's taking the majority of the time, then you can do a SQL Monitor for this particular SQL statement. But if you have a batch job that has like 100 of SQL statements and there's not really one that spends most of the time, again, I would do a SQL trace and use tkprof to get more information about the whole time that this batch job has been spending inside the database. It was on one of my first slides also. Is there a way to find the reason why the SQL throughput was reduced through SQL Plan Monitor? I'm not sure what you mean by this question. Does SQL Monitor help in analyzing a procedure which has multiple SQLs, or is it yeah, so SQL Monitor again would be just for a single SQL statement, not for a stored procedure that executes multiple SQL statements. For a stored procedure, I would use SQL trace and first capture all the SQL statements that are being used by this stored procedure, sort of like when you want to analyze a batch process. In the parallel tab, is it possible to identify a parallel queue execution times? Yeah, so it's possible in the parallel tab. You open up one of the parallel sets and then you should see database time not being equally distributed across the processes. There will be one process that has a spike. But again, diagnosing it then is a whole different story. I think it's, okay, that's just an answer. So is there a difference in SQL Monitor, what I showed, and SQL monitoring from EM? Well, not in terms of the underlying information. The underlying information should be the same. Honestly, I don't have experience with Enterprise Manager. I would hope that in Enterprise Manager, you can generate the JET-based version of a SQL Monitor and just get the exact same reports that I've been showing you in this talk. Why didn't the serial execution choose the smart scan? So that's the one where we got the index. That was because the statistics were not up to date. It only thought it would get 4 rows. Sometimes we're not able to see long-running SQL via SQL Monitor. Well, the only reason that I can explain why that happened is because the execution plan was more than 300 lines. How can we improve cell offload efficiency? Well, you can't improve that. I mean, it's the optimizer chooses when it does a smart scan, which filters it will push down into the storage cells. And those filters then determine the cell offload efficiency. So if you want to improve cell offload efficiency, you'd have to go back to the SQL text and understand the SQL text and see if maybe the SQL text needs to be rewritten such that more filters can be pushed down. Yeah, but that's a whole different ball game. I mean, there's not a DBA knob for you to just improve cell offload efficiency. Many cases, table stats changed due to table very high DML. How we resolve the same? Yeah, this is a difficult question. Sometimes you have indeed, instead of still statistics because a big load happened, they are just still because lots of DML is continuously going on. One solution direction that you may try to pursue is see if dynamic sampling can help in those cases. If you have a structural SQL statement that suffers from this fact that the statistics quickly become inaccurate because there's so much DML going on, it might be useful to inject a dynamic sampling hint into that SQL statement with a level that's higher than the default level 2. So maybe look at dynamic sampling there. When it comes to parallel query, how can I find the duration of the SQL execution time when analyzing historical? I'm sorry, I'm not sure how to answer that one. Okay, so if a query uses multiple plans due to reasons like peaking, how can it be defined in SQL Monitor? Where does it show that? So in a SQL Monitor tab, the examples that I had so far did not have bind variables. But in a SQL Monitor, if you go to the SQL text, if you have bind variables, which I don't have here, I have literals, there will be a top section here. There will be a top section here that shows the bind variables. It shows the bind variable names as they are in the SQL text, and it will also show the values that were peaked. Yeah, so if you have two SQL monitors of the same SQL statement with different peaked values and different execution plans, then you know exactly the values that were peaked for that particular case. Okay, other questions? That's one we already had. Right. Cost column, yeah. Are the estimated rows and actual rows always displayed in the report? Well, they should be, yeah. So interesting to see when they would not be. Will SQL Monitor generate recommendations to improve performance? No. It's you will have to do the diagnosis. SQL Monitor just gives you all the base data, and it's then up to you to try and understand the root cause and see how to fix it. Are there any plans to include stats histogram breakdown information in the upcoming SQL Monitor releases? Unfortunately, I'm not aware of this, but it might be a good enhancement to include the statistics in a new tab. Not sure what issues that would give rise to, because SQL Monitor might, of course, be of an execution that was parsed a long time ago. And you would need to have the statistics when it was parsed. So I'm not sure if it's even doable. So that was the remote query. How to identify whether SQL profiles used properly on SQL Monitor. So if a SQL profile was used by a SQL statement, it would show up in the plan notes. Remember the plan notes that I showed you? In plan notes, it would show you the profile name that was used for this execution. Can we run SQL Monitor for a current running long SQL ID? Yes, you can. Yeah, that's what I mentioned at the beginning. You run the SQL Monitor report function and you just provide the SQL ID and it will generate the report of the currently running execution ID, the most recent, which is the currently running. Is there any way to find the reason why the I/O throughput was reduced through SQL Plan Monitor? Not in a SQL Monitor. You can't. So if you see in a SQL Monitor that the I/O throughput suddenly reduces, I would honestly not know how to see the reason of that in a SQL Monitor. You would have to maybe start looking at the storage system at that time and maybe see what's going on in the storage system, why we get much less throughput I/O-wise. Can we access SQL Monitor for old SQLs that have been aged out of cache? Well, only if they were captured in the AWR workload repository, yeah? Where we capture every minute the top 5 ones, and only if they were captured there, but then you would have to use the other stored packaged function that I had on my slide to get the SQL Monitor. Okay, I think I've went through most of them. If I'm just going to offer you this here, right here. If you have a really important question for yourself, don't hesitate to send me an email. I'm happy to look at it in an email after this session. You can deduce my email ID, just firstname.lastname@oracle.com, and I would be happy to take a look at them later today. And with that, let's close it up, Simon.
Yeah, thanks, Toon. There are like 45 questions. It's really important. Yeah, I think, a lot of, we have learned so much today, actually. I think only thing is we need to practice a couple of times to keep it in mind because too much to learn in the performance tuning. So thank you very much. I think you spent really a good time with us today, Toon, and we like to see more sessions coming from you. I'll definitely come back to you with the other slot. Guys, please reach out to Telegram group if you have any questions, general questions on AIOG. And also congratulations to Kishore, Rahul, and Arvind, right? So thank you very much. Again, we'll definitely send your email, during the weekend. Apologies if I've not received any emails in this week. Thank you very much for that. So please keep asking more questions, right? That's very important, right? And that way, if something is really good questions, we can go back to the product development team and say, include that particular feature, right? So this is a really good forum where you can ask, what you want, right? And what is coming, again, we are not closing this performance month. So the performance month is, it's really great speakers are lined up, upcoming sessions. So we have Danny, Anil talking about Oracle Rack performance, and Prabhakar talking about the new release of 13C. And also we have where we can improve in the security in terms of performance, and also how to cheat extreme database performance. Let's hear from Douglas. And with that, thank you very much for joining today's session, and we'll see you next week, Wednesday. With that, we are closing this session. Bye.